Okay, so giving another update today on the progress with Cultist Astronaut. So today we did a little bit of design work. Harlan came over, so we were able to hash out some ideas for the Flayed King, which is one of the bosses in our game for the Flayed planet on planet Excoriya. And we felt that the Phase 2 was very lackluster. Phase 1 is also kind of lackluster, but it's not as bad. It just feels like Phase 2 is a lot of the same as Phase 1, except he can fly. And if you played our game, you'll know that he walks back and forth trying to slash you in Phase 1. He summons some minions, and he also has some like razor attacks. And then Phase 2, he has a fake death, and then he revives, and then he flies around with his jetpack capabilities and slashes at you, which is intimidating. So it has that aspect, but it's not as epic as we would like. So we wanted to highlight the fact that he's the Flayed King and he has an arsenal of swords and blades. So we came up with an idea where there's 3 variants of swords. There is a guillotine / cleaver type attack weapon that comes off from the background and basically chops downwards. And we have this idea that there's places you can hide in the ground. We do have a crouch ability now, so if I launch the game, you can see that we do have crouching, so we could use this to hide, although this crouch doesn't look like it goes down very far. We can tweak that. So there's that. And then the other idea was you could make it much larger, so this covers like a much bigger part of the screen, so it's harder to dodge, but there's gaps within it that you can hide. So that could be fun. The second idea is we have a spinning blade, and this sword can move in all directions, and it moves slower, but it spins, and it chases the player around, so you might get into a tight spot where it's hard to dodge. So we can design the level in such a way where this can be a deadly weapon. Blade 3 is, I forget what I called it here. I think it's called the Slicer. This one shoots horizontally. It's similar to number 2, but it can't go backwards. And it moves much faster, so it shoots forward. And then it can change or course correct based on where the player is. So it can go up and down, kind of chasing the player vertically. And then it shoots across the screen horizontally. And it may make a couple rounds back and forth before it goes away. And of course, when the sword is done performing its series of attacks, it will go back to the background. And you can also destroy these weapons. So they have health, and you can shoot them, blow them up, and then they won't reappear. So you can actually remove them from his arsenal. And then I wrote out a little series of attacks that we can use for the king during Phase 2. And this will basically be the order of events. So king dies, health is at 0. Visually, right? So the player's like, what's going on? He's dead. Why is his body still here? Typically, enemies blow up or explode or have some kind of feedback. And then he revives after the Slicer sword summons. So you see the summoning happening, like what's going on? It slices the king in half, which detaches him from his legs, and then he flies up, right? He hovers up, and then Phase 2 begins, and then the Slicer sword tries to slice you, and then it switches to his basic attacks that we already have implemented, and then we go through all the swords. And we're going to prototype this and see if we like it, but this is just us brainstorming. And then Harlan drew up basically what the Slicer sword could look like. So he's thinking of making these ethereal swords that like target onto you and then they slice forward. That's based on this idea here. And then Harlan did send me over some sprites. So I do have, if we go to the project, and this is the wrong Cultist Astronaut. I need to go to the new Cultist. We do have a new sprite for the demon sword here. So that's what these are. Looks very nice. So that was what we did for design today. On the programming side, we actually expanded the entity system. So what I've done is I've added component types to make it easier for us to search for a component. And I may adjust this based on ease of use, but for now this seems to be pretty solid. And then of course we have a new component structure, and this is like our base structure for all components, and it stores a type and an entity ID, and then we're using very, very light inheritance in order to give those same properties to the sensor and the sprite. And in C++, unlike C#, you can think of this as just like a pointer offset. So when we inherit the component, we're putting this at the top of each class. So that's what you can imagine. It just like injects that here, and then it gives you basically a pointer offset. We're not going to use any like functions or virtual functions within this. I don't believe in those. You can just write a function outside of these structures that process a component or a sensor, etc. There's no need for it. And of course, you can just use function pointers, which I'm actually doing right here for collision callback. So we'll look at that next. But yeah, sensor and teleporter are new components that I've added today, and they plug right into the entity, which right here you can see we can figure out. We can actually look at an entity and say, hey, how many components does it have? And then we can query against this collection to find a component. And if you look here, we actually wrote a function called GetComponent, which is reminiscent of Unity, where you can plug in an entity and the type, and it will basically find that component. And just like Unity, this can be expensive if there's tons of components, which is why you would cache this somewhere. And we are doing that. We are caching this when necessary. Although typically when you process a batch of components, you're not jumping around like this. You're actually just iterating over all the sprites, over all the sensors, etc. And I'll show some of that code. So this is more ECS than it is, game object component model, which is what Unity uses. And Unity is switching to an ECS model for performance reasons, and this is more ECS-like, as I'll show in a bit. But we do have this capability if you need to do very specific things in the rare occasion, right? Rendering sprites, that's a very common thing you do every frame, whereas like interacting with a door, pressing E, that only happens once per frame if you press E. So that's very uncommon, so the performance is very low, or very you don't have to worry about the performance too much. Although this isn't slow, this is actually a fairly efficient way of finding a pointer to a component. So yeah, we have the capability of grabbing components now, and then like I said, we've added sensor and teleporter, which means that in the text file for world, we've actually simplified the teleporters to entities. Now it's actually more verbose. You can see there's more text files, but it's actually more customizable. So there's no more teleporter start, teleporter end. It actually just goes through here and loads in the sprite, the sensor, and the teleporter with all the information that it needs. This is great because yesterday we didn't have the ability to create a sprite on the teleporter, but now we can associate a sprite with a teleporter using this. I still don't have entity references, aka like prefabs, so a lot of this is just like copy paste, but when I get to it, we're basically going to compress this file down to just entity references, and then of course we can override what we need, which will probably be just like this linked ID and room ID. Everything else should be part of the prefab, like the size of the collision and the sprite we're using. And then we'll create, different entity references for different types of doors. And then, yeah, this file will be much, much smaller. But that was done today. And if we play the game, you'll see that we can actually see where the doors are. So With sprites, we don't have offsets or pivot points. They're called pivots in Unity. And we also don't have PPU. PPU stands for pixels per unit, which tells the engine or tells the renderer how big a sprite should be relative to your unit system. And so in our game, a unit is the size of a tile. And so if I say, okay, the PPU is 100 pixels, then this picture will change size based on that definition. So if this picture is 200 pixels in width, then it becomes 2 units. So it's like a division. And Unity actually has this built in. Like if you look at, like, for example, this inspector for this blade, you'll see that the pixels per unit is set to 100 by default. And for some of the sprites, we do change this. So what I'm going to do is I'm going to associate this with the sprite. I have to make like a sprite index. It's kind of like an asset index where you have all your sprites. And then when I export these out of Unity into the new engine, I'll translate this over to our new sprite index. We don't have that yet, so this is off kiltered, and the scale is 2 by 2 for now, so it's in the wall. But hey, you can attach sprites to entities and they render, which is nice. And of course, the logic is still working, so you can actually teleport to each one, and you can see there's like no lag, and that's because we're only rendering tile maps right now. But also, there's no crazy Unity magic happening with instantiations and all that stuff we were doing for each script. So as we expand this should be more performant and more tailored to Cultist Astronaut, instead of us having to constantly find ways of making the performance work in Unity. But yeah, this is working pretty good. One thing I haven't showed off is we do have new wall jumping. It does still kind of flicker back and forth. That's something I'm looking into improving. But you can actually like hold your guy in place. And then of course you can double jump off of walls, which is very helpful for doing things like this. So you have more mobility, which we felt was better for the game. And oh yeah, you can kick. We've added that with the new animations we're doing. We'll keep refining the platforming, but it is much simpler than it was in Unity, which is what I like. So yeah, we got the teleporters ported over, and then collision. So with the sensor, what you can do is you can actually associate a callback with the sensor component. And this is just a pointer. So this is a pointer to a function that takes in a entity, which is the entity associated with the sensor, and then for now I'm just checking against the player. So you can't do any entity can't collide with any entity. So far it's just saying, hey, is the player colliding with any sensor? So that's how it's programmed today, but I have a to-do here to expand it to other entities. And that might require some optimizations, and I might use rooms for that. So basically right now we're just iterating over all the sensors in the room. There's not that many, so it's not a big issue. But if we add tons of stuff, well, we want to just like check the collision for just the room, right? If the player is in room 1, then we just say, hey, is the player colliding with anything in room 1? And we can do the rest for all the other entities. And then, of course, not all the rooms will be loaded, so that will dramatically help. So this is how we're like chunking the world and making sure things are running as fast as possible. But basically, when we load a teleporter in, we're using this function. This is plugged into the sensor, so using our new GetComponent, we can grab that from the entity that we pass in, and then we can use it to set some values on the player. So we say, hey, the player can teleport to this ID, and we say, hey, he's colliding with that. And we're using a Boolean for now for that. I mean, you would do that anyway for a teleporting component. Whether it should be on the player or not is another question, but hey, this works. It's efficient. So we got that in. And then, of course, when the player... this is our tick player function where we do all the inputs. So we do have like a basic input system that I've implemented. This currently wraps the Windows input. And this is really nice because we can essentially like port this over to other operating systems like Mac and Linux and just integrate another wrapper. Really, it's just like this is the interface, and then underneath it we have the functions. And this is, when I say interface, I'm not talking about a classic object-oriented interface. I'm talking about like, hey, this is a header file, and then you can implement it with a CPP, which is much better than which is much better than an interface, like an interface that we are familiar with in modern languages. And then I have like this to do for like caching, because right now I kind of just like cache it manually. So this can be improved. I know other engines will do this for you, but maybe this isn't necessary. I'm caching it right now just to make it fast, but maybe this isn't needed. It just depends on like performance, but this only happens when you press E, so it might not even be that bad. And again, like it's just grabbing a pointer that we access down here, so it's probably negligible. Yeah, and how do we do collision? So like I said, we're taking like an ECS approach, which means that we're iterating over arrays. So everything I showed you up to now is like very specific, happens like once per frame at very specific times. What I'm going to show you next is basically ECS in a very simple way. So here's where we submit all of our graphics to the GPU. So these are just commands that say, hey, use this shader, use this buffer. This is where you get into like the DirectX, OpenGL stuff. We're using DirectX right now, but we will be adding support for OpenGL in the future. So this will become more generic. Like instead of like, here's a specific vertex buffer function for DirectX, it'll just be like, hey, set vertex buffer. And then behind the scenes, it will use DirectX or OpenGL based on your platform or based on some configuration setting. But anyway, where this becomes more ECS-like is right here. So you can see we're grabbing the sprite array. So this is a pointer, but it's just an array behind the scenes. And we have the sprite count. And then if there are any sprites in the scene to render, then we set up all the information for the shaders to run. This is basically a method of batching, because all of these sprites will use the same shader, at least for now. And then we grab all the entities, or really, this is an old comment. We grab all the sprites. We grab their texture. In the future, I'm going to batch sprites that have the same texture. So if you have like 50 objects that use the same texture, then we'll just render all 50 objects together instead of separately, and that will reduce the amount of commands we're sending to the GPU. We generate our transformation. This is fairly quick. And then we update that on the constant buffer, and then we tell it to render. But we do that all in one big loop. So that's really nice. And this is what I mean by ECS. And the game state literally just packs all these sprites together into an array that we can loop over. Same with the entities. Arguably, we could make this more performant because we are looping over like one array and another, but I was looking at some cache stuff and it seems like both of these can be loaded into the cache at the same time. Still need to do more research and do some measurement on this, but this is a small, simple game, so this is probably, good enough. But I am curious to do some like performance testing on this. And yeah, that's how we render all of our teleporters to the screen. I'm trying to think about what I did after that. Yeah, so we're working on the sword. I did get the sword loaded in using the new entity structure. So down here you'll see I was able to hard code this into the text file. I need to make an editor that allows us to create new entities and place them into the world, but that will be something we do later this week. But for now we have basically the sword is just a sprite and a sensor, and then my next goal is to create a damage component that we can use to damage the player. So we can do something like this where we say it does 5 damage, and then the damage type is let's see, I think it would be piercing, or I think we might have razor. but you get the idea. We can do something like this. And then, of course, you can destroy these. So we'll give it a component for health. And like I said in the last video, these are just like really simple property components. They're not behavioral. They can become behavioral based on what we do on the code side, but really the designer / artist is just manipulating these fields. But this is next on the list, is the health and damage component that we'll need. And we'll be putting that on the player. The player doesn't use the entity system yet, so that's something that I need to do. And then we can give the health component to the player as well as the sensor so that they can interact with each other. Although I don't know if we need a sensor on the player because it's more of a trigger thing, whereas the player is more of a solid. So we'll figure that out. But yeah, that's the update for today. Tomorrow I'm going to continue working on the sword. I'll show what this looks like actually. So this is where PPU, pixels per unit, come in, because if you look at this, it is stretched, it is offset, and this collider needs to be adjusted to fit it. And this is where an entity editor will be useful. So yeah, that's the update for today.